Hello my dear students, in this session we are going to derive work energy theorem for a variable force. This question usually be asked in the board exam for 5 marks, and this concept is also important for NEET and JEE. What is work energy theorem? The change in kinetic energy of a particle is equal to work done on it by the net force. So what we have to do, work energy theorem for a variable force means we should use method of calculus. Okay. So what we'll do first, okay, we'll consider a particle which is moving with some kinetic energy k is equal to half mv square. Okay, we'll start from this equation. Now, change in kinetic energy we need, correct? Now, if we differentiate this, I get dk. Dk means what? Very, very small change in kinetic energy. So it would be easy for me to derive. Okay, what I'll do? I'll differentiate this equation. I'll differentiate with respect to time. If I differentiate the above equation with respect to time, what happens? Okay, on both sides. Okay, on both sides. Now what happens? dk by dt will be equal to differentiation of half mv square. Hope you are making notes. Okay, dk by dt is equal to differentiation of half mv square. Okay, or dk by dt is equal to half is a constant, m is a constant, correct? Now half m into differentiation of v square. Now here, what is differentiation of v square? See, this is very important. Okay, see, differentiation of, I'll explain you. Differentiation of, okay, t square. Okay, differentiation of t square is equal to 2 into t power 2 minus 1, correct? Now basic differentiation formula I have taught you, just go through that if you don't understand. Okay, differentiation of x power n with respect to x is equal to n into x power n minus 1, correct? Now what is differentiation of u power n? Differentiation of u power n, if u is a function of x, differentiation of u power n is equal to n into u power n minus 1 into du by dx. Is very, very important. This is a difficult step in the derivation. Okay, so similarly, differentiation of u power n with respect to t, if u is a function of t, then it is n into u power n minus 1 into du by dt, This formula we have to use. See what is here? I am differentiating v square with respect to t, but v is a function of t. So therefore, I should be using the equation differentiation of u power n is equal to n into u power n minus 1 into du by dt, since this is a function of time. Otherwise simply we could have stopped here. Okay, so what happens? Dk by dt, this is very important, dk by dt is equal to half into m into differentiation of v square is equal to 2 into v power 2 minus 1. Okay, 2 into v power 2 minus 1 into dv by dt. What happens? 2v into dv by dt. Or what you can do to differentiate this? Okay, differentiation of, one more method is there, easy method. I am telling you easy method now. So differentiation of v square with respect to t, what you can do, this can be written as differentiation of v into v. You can write differentiation of v into v. First function, second function. What happens? Differentiation of UV formula, chain rule. First function into differentiation of second function plus second function, that is also v, into differentiation of first function. So what happened? V dV by dt plus V dV by dt is equal to 2V into dV by dt. We got the same answer. Okay. So whichever the method is easy for you, you can use it. If it is difficult, you forget it. Okay. Differentiation of V square we have to do. So differentiation of V into V. Okay. First function into differentiation of second function plus second function into differentiation of first function. So V dV by dt plus V dV by dt, what happens? 2V dV by dt. Now what happens? This 2 and 2 gets cancelled. 2 and 2 gets cancelled. So dk by dt is equal to m into v power 2 minus 1 means v dv by dt. What is dv by dt? Acceleration. So here I cannot cancel. I will not cancel dt and dt. Why? Because I want force. I want force into displacement, because work energy theorem means change in kinetic energy equal to work done. So that is why if I write it as acceleration, I get m into a equal to force. Okay. dk by dt equal to mva. I'll write this. dk by dt is equal to mva. Okay. What is m into a? M into a is force. Force. What is v? V equal to dx by dt. V equal to dx by dt. Now dt gets cancelled. So dk is equal to f into dx. dk is equal to f into dx. So now if you integrate, you will get, so integration of dk is equal to integration of f dx. Say a particle goes from initial position xi to final position xf. When the particle is in the initial position xi, say corresponding kinetic energy is ki and corresponding final kinetic energy is kf. Okay. Now, what is integration of dk? Integration of dk is k, correct na? What is integration of dx? Integration of dx is x. So integration of dk is k. So between the limits ki and kf is equal. What is this? Definite integral of force over displacement is equal to work done. We have studied work done by a variable force. Correct na? So what happened? Kf, apply the limits. Final kinetic energy minus initial kinetic energy is equal to work done. So this is work done, work energy theorem for a variable force. Okay. So don't get confused. Okay, I'll explain you in very simple manner once again. Okay, very fast, within 1 minute. Kinetic energy equal to half mv square, differentiating on both sides with respect to time. dk by dt is equal to d by dt of half mv square. Okay, so dk by dt is equal to half and m are constants, half m into differentiation of v square, differentiation of v square, differentiation of v square. I am writing v into v. So first function into second function. So what happens? dk by dt is equal to half m into first function into differentiation of second function plus second function into differentiation of first function. What happened? v dv by dt plus v dv by dt. So 2 times v into dv by dt. So dk by dt will be equal to half m into this 2 times. Correct na? Correct na? So 2 into v dv by dt. Okay, so 2 and 2 gets cancelled. dv by dt means acceleration. M v into a. What is m into a? M into a means force. F equal to ma. So dk by dt is equal to force into velocity. Velocity means dx by dt. Why I am writing v as dx by dt? Because I want f into dx. I want work done na. dt gets cancelled. So now what happens? Integration of dk is equal to integration of f dx. Say the particle moves from xi to xf. Okay. Say the kinetic energy changes from initial kinetic energy to final kinetic energy. Integration of dk is k between the limits ki and kf. Integration of this, integration of definite integral of force over displacement is equal to work done. Now applying the limits. Final kinetic energy kf minus initial kinetic energy ki is equal to work done. Derivation is very simple. Only thing is, so here in this step, so you should differentiate properly, and you should not cancel this dt now. Okay, because I need force. Okay, hope you understood the derivation, or else once go through it once again. It's just 5 minutes. Okay, thank you very much.